Hi, welcome to this video. Vector search is an Azion Edge SQL feature that enables customers to implement semantic search engines. While traditional search models aim to find exact matches, such as keyword matches, vector search models use specialized algorithms to identify similar items based on their mathematical representations, or vector embeddings. Vector search is used in Azion Copilot, Azion's AI-powered assistant chatbot. It enables more relevant searches and personalized recommendations by finding items similar to or aligned with user preferences, such as products in e-commerce or content on streaming platforms. It also supports searching for semantically similar text and AI applications with NLP, such as voice assistants and chatbots. Distributed across Azion's global edge network, it reduces latency and enhances the user experience by providing real-time recommendations while maintaining data locality and minimizing reliance on centralized databases. Let's now look at an example of vector search implementation. This code performs a vector search in a database using the Langchain library for embeddings with OpenAI and the Azion Skill Database API. The first step of the function is to check if the database called vector database already exists. If the database is not available, it is created using create-database. Next, the code defines ACL instructions to create a table called documents. This table has three columns: ID, which is the primary key, content, which stores the text of the document, and embedding, where the vectors with 1536 dimensions, corresponding to the embedding model used, are stored. In addition to the table, an index called documents_idx is created, which uses the libscil_vector_idx function to perform vector searches more quickly, utilizing cosine similarity as the similarity parameter. Then it initializes the embedding model, configuring the OpenAI text embedding 3small. The code then defines a list of documents related to France, England, and Brazil, and for each document, it generates a corresponding vector using the embed query function. Each generated vector is incorporated into an insert SQL statement, which inserts the text and its respective vector into the documents table. After inserting the documents into the database, the code performs a vector search. It generates an embedding for the query, "What is the capital of Brazil?" using the same model that was used for the documents. With the query vector ready, the code prepares an SQL statement to find the two documents most similar to the query vector, based on the previously created index. This query is executed with useQuery, and if successful, the results are returned in the response. To run our application, let's create it locally with the Azion build command. Once created, we will start a local development server for the current application with Azion dev command. While our application is running, we will query Azion Edge SQL to observe the creation of our database. And after executing the function, we can confirm that our database has been successfully created. Now, let's send a query to our local host with the value, "What is the capital of Brazil?" The server is expected to interpret the query and return an appropriate response. The server returns a vector representation of the query, and we receive a list of documents that are most similar to the query. As we can see, when searching in the Edge SQL shell, we find the information that was inserted into the documents table of the vector database.